Hi, this is Jeff Spencer, Math 120 instructor for the Community College of Denver, and this is an extra video doing examples from 3.5, variations on the conditional statement. So I just want to make an example video doing a couple more examples. So we'll start with a statement, a compound statement. We'll write it out as a conditional, which is a if P then Q. Then from there, once we have that form, we'll be able to go from the conditional to the converse. So the conditional is if P then Q, the converse is if Q then P, the inverse is if not P then not Q, and the contrapositive is if not Q then not P. And then the biconditional is with an if and only if in the middle. So conditional, remember, is a if P then Q, which really means that if the condition of P is met, then the consequence or the result of Q will happen. So we got to be able to understand that logically, that this Q really depends on P happening. Well, that's not entirely true, excuse me. If we just know that if P happens, then Q will happen. So this one says, I can't work whenever the sun is out. So the limitation of working is based off of the sun being out. So the sun being out is the condition, and not being able to work is the result. In other words, whenever has the same logical meaning as if. So this conditional statement will be if, not do this in bold, if the sun is out, then I can't work. And that has the same exact logical meaning as this statement, but I'm just writing it in the traditional if P then Q form so that I can write the rest of these out using the form here that we see from the lecture video and following this box here. So the converse then, so P is sun is out, Q is I can't work. So then this would be if I can't work, then the sun is out. The inverse is if not P, then not Q. So you just negate both the P and the Q, but keep the same order. So this one's going to be if the sun is not out, then I can work. So I just negated both of the original things from the conditional. The contrapositive is negating both of them, but also switching the order. So I have to start with if the sun is not out, then I can work. So this is something I went over in the lecture video before, but the conditional and the contrapositive have the same truth value. They mean the same thing. They're equivalent statements. So if the sun is out, then I can't work is equivalent to if the sun is not out, then I can work. Finally, the biconditional is the sun is, the sun is out if and only if I can't work. So basically you just look at P and Q, you remove the if then and put the if and only if in between the two statements. Okay. Next one is when we give him candy, Spence is smiling. So the when, just like here, when is basically the same thing as if. So this is basically if we give him candy, then Spence is smiling. That's the conditional here. So if we gave him candy, then Spence is smiling. So gave him candy is P, Spence is smiling is Q. So the converse is going to be the reverse of that. If Spence is smiling, then we gave him candy. The inverse is the negation of both of these. Remember, it's the negation of P and Q, but keep it in the same order. Remember, P is give him candy, Spence is smiling, is Q. So if we don't give him candy, Spence won't be smiling. Okay, then the contrapositive is we negate both of them but flip them. So the first one's going to be if Spence is not smiling, then we didn't give him candy. And then the last one, the biconditional, is just take the two statements and then put an if and only if in between. So we say, we gave him candy, or give him candy, if and only if Spence is smiling. Okay, so there's a couple examples to look out for. Just remember that when or whenever has the same logical meaning as if. You want to write the original from take the compound statement and write the conditional as a traditional if-then statement, and then you can basically use the form to switch around the P and the Q and or put negations based on whether you're doing the inverse, converse, contrapositive. All right, see you next time.